Datalynx is a specialist data management company that since 2005 has been working with our customers to resolve some of their most challenging data management issues. One such challenge that Datalynx was presented with was a need to migrate legacy systems to a client's chosen cloud platform, including integrating reporting solutions. This video outlines the Datalynx solution to address the hidden dangers and costs of clinging to legacy applications just for compliance or regulatory purposes. Here is why you should be concerned. Outdated tech. Legacy systems often rely on aging technology stacks, making updates and maintenance a complex and expensive burden. Technical debt. Years of quick fixes and patches without proper code refactoring create a tangled mess of technical debt, further hindering future maintenance. Shrinking talent pool. As newer technologies gain traction, skilled professionals who understand legacy systems and languages become increasingly scarce. Security risks. Unpatched vulnerabilities in older systems are prime targets for cyber attacks. High maintenance costs. Maintaining legacy systems requires specialized skills, outdated hardware prone to repairs, and expensive licensing fees for both software and hardware maintenance. Datalynx, your partner in data management. Datalynx developed DMS, Data Management Suite, Phoenix to alleviate these risks and costs. DMS Phoenix migrates data from legacy systems to your chosen cloud platform and makes the data available to a broad range of BI, business intelligence, and reporting solutions. Since 2005, Datalynx has helped numerous enterprises and government departments tackle their most challenging data management issues, including those related to legacy applications. We can help you. Migrate data seamlessly to modern systems. Retire legacy applications while ensuring continued access to critical data. Reduce compliance burdens associated with outdated technology. DMS Phoenix offers a solution by transforming data from a technical representation which can only be understood by the front-end application into a business context that can be understood easily by a businessperson. Facilitating the migration of data from legacy systems to modern cloud-based platforms, ensuring easy data accessibility and avoiding vendor lock-in. Helping organizations meet legislative compliance by maintaining data integrity and audit trails. Ensuring data remains usable for generating reports and conducting historical analysis even after migration, supporting data utilization and analytics. In essence, Datalynx DMS Phoenix bridges the gap between legacy systems and future needs, ensuring critical data remains accessible and valuable for evidentiary purposes, compliance, and analytics. To provide an insight into DMS Phoenix, let us walk through the workflow of the Datalynx DMS Phoenix solution. The process starts with the source data, which can reside in a broad range of data sources such as Oracle databases, SQL Server, ERP, enterprise resource planning, systems like SAP, text files, or other databases. We refer to this source as the Source Data Model, SDM. For the following discussion we will use a sample SQL Server database named AdventureWorks. As the first step in the process, we use the Datalynx product, DMS Data Explorer. With innovative automation, DMS Explorer empowers you to gain a comprehensive understanding of your data in record time, minimizing both time and costs. Using Data Explorer, you can quickly register the data from the AdventureWorks database. Once registered, you can analyze the metadata of the source tables and generate a detailed metadata report for the SDM. The metadata report contains a record count for all tables and highlights if there are any attachments in the source database based on the column binary type. This report can be saved to your local machine for ongoing analysis. After analyzing the source data, we use DMS Data Exchange to extract the CSV files. We start by setting up a template that connects the source to SQL Server, AdventureWorks database and the destination to files. Then, we use the Import from Data Explorer option to automatically import the sequences quickly. We assign a file folder code, defined in the File Folder section, to specify the location where the files will be saved. Then we click on Import button and use the default SQL statement. This imports all the tables, assigning one sequence for each table. Once all the sequences are imported, we assign file headers to each sequence by clicking on Generate All Destination File Header Record. Once all the template configurations are finalized, we finalize the template and submit the job. Once the job is completed, we verify the files on the location defined. Let's consider a scenario where a source table contains 100 million records. Extracting all 100 million records into a single file is not a good option. Instead, we split the data into multiple files based on specific attributes of the table. For example, we can extract the data year-wise using a date column or by using the last digit of a numeric column. We then register an Exchange template and create different processing sequences based on the chosen logic and the number of files. Let's select the person table and divide it into 10 files based on a specific logic. Similarly, create 10 processing sequences. After finalizing and submitting the job, it will generate 10 CSV files at the designated location. This approach allows you to extract data into multiple files and append it in the destination effectively. Once the extraction of files is done, we register the CSV files in DMS Data Explorer. We then apply the record count profiling function to both the source database and the CSV files template. Finally, we generate a reconciliation report to compare the record count between the source and the CSV files. For detailed instructions on generating a reconciliation report, please watch Data Explorer, ETL Job Comparison, Lesson 20, on the Datalynx Australia YouTube channel. Upon analyzing the metadata report, we found that the source database contains attachments. Therefore, we need to extract these attachments also. We will create a template in DMS Data Exchange, setting SQL Server as the source and the destination as a file. We'll use the Import from Explorer option to generate a sequence for the document table. Next, we will create a virtual column to define the location of the output file. Give it a name, choose the data type and length, then click on the 3 lines to assign the mapping rule. Copy the location and append it with a unique column and the extension .rtf. We will then create a virtual column to define the file names. Give it a name, choose the data type and length, then click on the 3 lines to assign the mapping rule. Assign the file name as the table name and append it with a unique column and the extension .rtf. Please watch Lesson 13, DMS Data Exchange Template Virtual Columns, on the Datalynx Australia YouTube channel for more details. Move to the destination and double-click on the document column that has attachments. Select the built-in data exchange function, Save to File. Select the document column and enter the virtual column names in the pop-up window, then click OK. Finalize the template and submit the job. As you can see, DMS Data Exchange has extracted all the attachments into files. Next, we utilize a special feature of Data Explorer called reverse engineering. This functionality examines the relationships between all the source tables and generates a data model discovery, also known as an entity relationship diagram, ERD. To proceed, we access the reverse engineering feature in Data Explorer. This feature is available only in the Phoenix module, and requires a Phoenix license placed in the relevant folder, along with the necessary metadata access permissions in the security system. Click on the Phoenix button and select Reverse Engineering. This will open the Reverse Engineering Jobs interface, which offers 2 functions. 1. Screen Data Discovery. This function examines the data in the front-end application and identifies the associated tables that store this data in the database. 2. Data model discovery. This function examines and maps table relationships, creating an ERD diagram. For more detailed information on reverse engineering, please visit our Datalynx YouTube channel, Datalynx Australia, and watch the video titled DMS Data Explorer, Reverse Engineering, Lesson 29. Next, we move the CSV output files to the client's chosen destination, which in this case is a Google Cloud Storage bucket. We will also transfer the attachments to Google Cloud Storage. To accomplish this, we will use DMS Data Exchange and create a new template, source as delimited and destination as plugins. Then, we will use gsutil, a command line tool for interacting with Google Cloud Storage, to upload the files and attachments by specifying the from location and to location, along with log location. Then create a destination table. Then finalize and submit the template. Once the job is complete, check the log file for any issues and verify the files in Google Cloud Storage. Next, we build the Transformed Data Model, TDM. The ERD diagram generated from reverse engineering helps in constructing the TDM, which is a simplified data model reflecting the business context of the data, including parties, relationships, and transactions. We next build the TDM repository in any destination of your choice, such as an Oracle database, SQL Server, Snowflake, AWS, Amazon Web Services, S3, and any other database. In this case we will use SQL Server for Phoenix repository. Let's go through each button in the Phoenix module in DMS Data Explorer. New button. The New button lets you create a new Phoenix repository. When you click the New button, the Phoenix repository registration interface appears with two tabs, Database Details and Description. Database Details tab. Enter the name and choose the source type from the drop-down menu. In this case, select SQL Server and enter the username, password, and database server name. Description tab, enter a description for the repository. Verify the connection by clicking the Test Connection button. Click OK to create the Phoenix repository. Close button. Click Close to exit the Phoenix repository registration screen. Connect button. Click the Connect button in the repository toolbar to show the list of repositories available. The Phoenix repositories pop-up screen will appear. This is where you can connect to any available Phoenix repository, modify it, or delete it. Disconnect button. The Disconnect button allows you to disconnect from the Phoenix repository once connected. Next, we begin building the Transformed Data Model, TDM, by connecting to the DMS Phoenix repository created before by clicking the Connect button. This brings up the Phoenix Workbench on the screen. To define a source system, click on the Source Systems button, which opens the Registered Source Systems screen. Click on the Add button to create a new source system. Then the Source System Registration pop-up window will appear. On this screen, enter a system name, agency name, and choose the source template for this source system by clicking on the three lines. Enter a description in the description box. Click on the OK button to create the source system. If you need to modify a source system, use the Edit button. Click on Edit button to edit the source system. Refresh option. If any changes are made to the source, SDM, that need to be reflected in the TDM, we use the Refresh button to update the Phoenix repository. Click on the OK button to update the source system or click Close if no changes are needed. If you need to delete a source system, use the Delete button. You can also export all the source systems to a local machine by clicking the Export All Relationships Type Mapping button. Once done, click the Close button to exit the screen. Next, click on Party Types. The Party Types screen will appear, where you can define party types such as person, organization, and item, called as POI. The terms person, organization, and item typically represent different types of entities that need to be managed and have relationships between them. Person represents an individual, often with various attributes and relationships. In a database or system, this might include name, date of birth, gender, etc. Organization refers to a collective group or entity, such as a company, institution, or any structured group of people. Item usually refers to tangible or intangible objects that are relevant within the system. This could include products, assets, documents, or any objects of interest. Click the Add button to open the party type pop-up screen. Enter the party type name and description, then click Add to include more entries. Click OK to close the screen. Use the Edit button to modify a party type, and the Delete button to remove a party type. To export all party types to your local machine, click the Export All Relationships Type Mapping button. Finally, click Close to exit the party type screen. Next, click on the DB Scripts button, which opens the Generate TDM Create Table Scripts window. Select the System and Destination database, then click the Generate button to create the scripts for the TDM system tables. Once generated, right-click then Select All and copy to the desired location. We will cover Compile, Relationships View, and Transactions View in detail as the video progresses. Next, select the source system from the drop-down menu. For the party type, keep the default setting as All Party Types. Next is the workbench, which consists of 6 tabs: TDM Parties, TDM Relationships, TDM Actions and Transactions, Source Tables, Source Columns, and Search. Let's go through each tab. TDM Parties. In this section, we define parties and assign business names to all objects and their associated columns, performing any necessary transformations based on business requirements. To create parties, we use the ERD diagram, the output of reverse engineering, combining tables using one-to-one relationship into a single party by denormalizing and joining them. For tables with a one-to-many relationship, we create separate parties for each table. Based on the ERD output from reverse engineering, we have identified the parties and relationships between them. Now, we will build the TDM parties using data from this Excel sheet. Click on the New button to add a party. The TDM party screen will pop up. Enter the business name and select the source table from the drop-down menu. Choose the domain based on your findings, such as whether the source table falls under person, item, or organization. Assign the destination table name like TDM_P_source table name, ensuring table name does not exceed 30 characters. Provide a description of the party in the description box. If there are any references, lookups, or one-to-one relationships between the source tables and the person table, you can join them with the person table to create a single party, leading to denormalization. Click on SQL Table Joins to open the Query Builder screen. Choose the left table and right table along with the joining columns, select the type of join, and click on Add Join. Click OK to finalize the join. You can also add anywhere conditions to the SQL query. To do this, click on the SQL Where Clause button, which opens the Query Builder screen. Here, select the appropriate right table and the necessary columns, and specify the logical conditions to include in the Where clause. Finally, click OK to close the TDM party screen. For this demo, we will not include any where conditions. Click on the Edit button to modify a party. Click on the Delete button to remove a party. Next, we need to add columns to the party we created. Click on the Remove button in the Party Columns section. You will see 6 system columns related to the party, which we need to define first. Instance ID, this is the primary key column for the party. Select the Instance ID option to open the TDM Party Column interface on the screen. The screen is divided into 3 sections. Source databases, all fields are populated here, and you can verify the dataset and table name. Source columns, this section displays the list of columns available in the source table. Destination TDM column. Name, this is the technical column name. Business name, we assign a business name to the TDM column here. Type, select the data type for the TDM column. Length and decimal, specify the length and decimal for the TDM column. Transformation rule, describe the transformation rules for this column here. Data lineage enables the implementation of all transformation rules by specifying the source column. Since the instance ID must be unique, choose Business Entity ID from the source columns for the instance ID. Click the OK button to save the changes. Similarly, add all other system columns, instance name, status code, created date, last updated by, and last updated date. Finally, select the column option and add all required source columns to the TDM. Click the Add Column icon to add columns manually to the TDM party. Click the Close button to close the screen. Similarly, you can also add the columns from the join tables. Additionally, we have created more parties. The Import button is only enabled and a specific party type is selected at the top. The Import button allows you to import all parties at once from a CSV file instead of adding them manually one by one. Select the required file by clicking on the 3 lines, then click on the Import button to import all parties from the file. The Export button enables you to export all parties into a CSV file on our local machine. The Generate All Parties SQL Scripts button generates the SQL scripts for all parties created. You can right-click, select the script, and copy it to your desired location. Search box. The search box allows us to find any party ID or party name from the list of parties. Let's go through each button in Party Columns. Click the Edit button to modify the configuration of the TDM party column. Click the Delete button to remove the TDM party column. Delete all columns allows you to remove all columns related to the party at once. The Import option lets us import columns from a file instead of adding them manually one by one. Click on the 3 lines to select the file, then click Import. This will import all columns at once, but you will still need to add the 6 system columns manually. Import from Extract allows for a more flexible import of columns, including data lineage, transformation rules, and more. Generate Party SQL Scripts creates the SQL script for this party. You can right-click, select the script, and copy it to your desired location. Once all TDM parties and their associated columns are built, we will move on to TDM relationships. We will meticulously define the relationships between different parties, specifying precise joining conditions. We have identified relationships between the parties using the ERD diagram from the reverse engineering and assigned business relationship names such as associated with persons or organizations, for example, items owned by a person or used in an organization. In the Relationship section, click on the Renew button to open the TDM Relationship Type pop-up window. Enter the business relationship name and provide a description. Click the Add button to add more entries or click OK to save the changes. Click the Edit button to modify the relationship. Click the Delete button to remove the relationship. Click the Import Relationships Type button to automatically import relationships from a file. The Import from CSV screen will appear. Click on the 3 lines to choose the file, then click the Import button. An information dialog box will appear, displaying the total processed successfully, and rejected with errors. Next, we add relationship mappings to each associated relationship. Select the relationship and click on the New button to open the Relationship Type window. This screen has 4 sections: From Party, To Party, Intermediate Table, and Custom Intermediate Joins. Let's create a few relationships to explore all these sections. To create a simple relationship, first choose the party name and join column in the From Party section. Next, choose the party name and join column in the To Party section. Click OK to finalize or click Add if you have multiple entries. Now let's create a relationship with an intermediate join by using the Intermediate Table section. Choose the party name and join column in the From Party section. Next, choose the party name and join column in the To Party section. Then select the Intermediate Table and joining columns. Click OK to finalize or click Add if you have multiple entries. To create a relationship with multiple joining conditions or more than one intermediate tables, use the Custom Intermediate Joins section to specify the customized joins. Start by selecting the party name and join column in the From Party section. Next, choose the party name and join column in the To Party section. Then, type in the customized script. The script will include multiple joining conditions, as demonstrated by having 2 joining conditions. Click OK to finalize, or Add if you have multiple entries. Click the Export All Relationship Type Mapping button to export all relationships to a file in your local machine. Click the To Generate All Relationship SQL Scripts button. This opens a pop-up window asking for the TDM relationship dataset name. Enter the name and click OK to generate the SQL scripts for all relationships. You can right-click and select Copy to copy the script to your desired location. Let's explore the buttons in the Relationships Mapping section. Click the Edit button to modify the relationship mapping, such as changing the joining party or column. Click the Delete button to remove the relationship. Click the Generate All Relationship SQL Scripts button to open a pop-up window asking for the TDM relationship dataset name. Enter the name and click OK to generate the SQL scripts for all relationships. Search box enables us to search for relationships from the list. Next, we will move on to TDM actions and transactions. This section is optional and only needs to be filled if there are transactions or actions present in the source system. Click the New button under Actions and Transactions to open the TDM action or transaction type interface. Enter the name and select the type as either action or transaction. Provide a description in the description box. Click OK to finalize, or Add if you need to include multiple entries. To make changes to a TDM action or transaction type, click the Edit button. To delete a TDM action or transaction type, click the Delete button. To import transaction types, click the Import Transaction Types button. This will open the Import from CSV screen. Click the 3 lines to select the file, then click the Import button to load all transaction types. Next, we add actions and transactions mapping to each associated transaction. Select one transaction and click on New button. This opens TDM transaction mapping window on the screen. This screen has 2 sections: From Party and To Party. First, choose the party name, join column, date column and action column in the From Party section. Next, choose the party name, join column, date column and action column in the To Party section. Click on OK button to finalize. You can click on Add button if you have multiple entries. Similarly, we add transaction mapping for other transactions as well. Let's explore the other buttons in TDM Actions and Transactions. Click the Export All Transaction Types Mapping button to export the transactions to your desired location. Click the Generate Relationship SQL Scripts button to open a pop-up window asking for the TDM transaction dataset name. Enter the name and click OK to generate the SQL scripts for all transactions. Let's explore the other buttons in the Actions and Transactions Mapping section. Click the Edit button to modify the Actions and Transactions Mapping. Click the Delete button to remove the action and transaction mapping. Click the Generate Relationship SQL Scripts button to open a pop-up window asking for the TDM transaction dataset name. Enter the name and click OK to generate the SQL scripts for all transactions. Next, we will move on to the Source Tables section, which displays the metadata of all the tables in the source database. In this section, you can add new source tables or create derived columns for existing tables. New button enables us to add new tables to the source. Edit button enables us to edit the description of the tables. Delete button allows us to delete a table from the source tables list. Import button enables us to import the metadata of the tables. Export button enables us to export the metadata of source tables to your desired location. Columns button allows us to add new columns to existing source tables or new tables. Next, we will move on to the Source Columns section, which displays the list of all the columns in the source database. You can select the table from the drop-down menu to view the list of columns for the selected table. Next, we will move on to the Search section. This allows us to search for any keyword within the Phoenix repository. Let's search for person. This will provide us with a list of areas where person was found in the repository. Once the TDM build is complete, we compile the Phoenix data model by clicking the Compile button on the Workbench toolbar. A warning dialog box appears. Click Yes to continue. The Select Folder screen appears. Choose the desired location and click Select Folder. An Enter pop-up window appears, asking for the TDM relationship dataset. Click OK to continue. Another Enter pop-up window appears, asking for the TDM transaction dataset. Click OK to continue. An information dialog box appears, stating TDM scripts compiled successfully. Once the TDM build is done, we migrate TDM to any destination of your choice, that is Oracle Database, SQL Server, Snowflake, AWS S3 in BigQuery. Next, for our demonstration, we will utilize BigQuery, Google Cloud's fully managed data warehouse, which facilitates efficient data storage, querying, and analysis. By setting up datasets in BigQuery, you can structure your data effectively and conduct thorough analyses. We will create 3 datasets in BigQuery. AdventureWorks SDM contains data sourced from the original system. AdventureWorks TDM holds the data from the TDM we have built. AdventureWorks BDM stores queries or tables utilized for generating reports. First, we will load the data into the AdventureWorks SDM dataset. To accomplish this, we will use DMS Data Exchange, integrating with the BQ Load command line tool to load data into Google BigQuery. First, we will use DMS Data Explorer to generate JSON files on my local machine. Then, we will create a template in DMS Data Exchange to load data into the AdventureWorks SDM dataset. We will utilize the Import from Data Explorer feature to import the sequences for all tables in one go. Select the tables you want, then click the Import button. Pop-up window appears. Enter the SQL statement and click OK. This imports all the sequences automatically. Finally, finalize and submit the template. After the job is finished, you will see that the AdventureWorks SDM has been updated with data from the source. Next, We will use DMS Data Explorer to connect to the BigQuery dataset and generate a reconciliation report to compare the record counts between the source database and the BigQuery AdventureWorks SDM dataset. To enable DMS Products Data Exchange and Data Explorer to connect to a BigQuery dataset, you need to download and install the 32-bit Simba ODBC drivers for BigQuery on your local machine. After installation, access the ODBC Data Source Administrator by searching for ODBC Data Sources 32-bit in the Start menu. This opens the ODBC Data Source Administrator window. Navigate to the System DSN tab, select Google BigQuery 32-bit, and click Add. Choose the Simba ODBC driver and click Finish. The Simba ODBC driver for Google BigQuery Setup window will appear. Enter the required configuration details and test the connection. Once successful, click OK. Repeat this setup process for both AdventureWorks SDM and AdventureWorks TDM. After configuring the Simba drivers, connect to DMS Data Explorer and register a new template for the BigQuery SDM dataset. Set the source type to BigQuery and the destination to Demo AdventureWorks SDM. Upon successful connection, click OK to register all tables from the SDM. Next, apply the record count profiling function and generate a reconciliation report to compare the record counts between the source database and BigQuery SDM, ensuring no data loss. For a detailed walkthrough, refer to the Datalynx Australia YouTube channel and watch the video titled Data Explorer, ETL Job Comparison, Lesson 20. Next, we will migrate data from the Phoenix repository to the BigQuery TDM dataset using DMS Data Exchange. Data Exchange integrates seamlessly with the Phoenix data model. In the source section, set the database type to BigQuery and specify Demo AdventureWorks SDM as the database. In the destination section, also select BigQuery as the database type and enter Demo AdventureWorks TDM as the database. Select the Import from Phoenix option and choose Parties. Click the Import button to swiftly import all party data. This process is automated and quickly generates scripts for all parties. Once the sequences are automatically generated, finalize the template configuration. After finalization, submit the job for execution. Upon job completion, you will find that all parties have been created in the BigQuery Demo AdventureWorks TDM dataset. Similarly, you can create a new template to migrate relationships to the BigQuery TDM dataset. DMS Data Exchange will quickly generate the necessary scripts for all relationships. Select the Import from Phoenix option and choose Relationships. Check the Create Relationships table box, click the Import button, and specify the schema name for the BigQuery TDM dataset. This will import all relationships. After the sequences are auto-generated, finalize the template configuration and submit the job for execution. Upon completion, you will see that the relationships table has been created in the BigQuery Demo AdventureWorks TDM dataset. Similarly, you can create a new template for actions and transactions using the same procedure as before. Select the Import from Phoenix option and choose Actions and Transactions. Check the Create Transactions table checkbox, click the Import button, and specify the schema name for the BigQuery TDM dataset. This will import all transaction data. After the sequences are automatically generated, finalize the template configuration and submit the job for execution. Upon job completion, the TDM transactions table will be created in the BigQuery Demo AdventureWorks TDM dataset. Next, we will migrate the Phoenix system tables to BigQuery TDM dataset. First, generate the Phoenix system tables by compiling the Phoenix model. Click the Compile button, select the desired location, which downloads the system tables to chosen location. The tables will be downloaded as CSV files. Upload these CSV files to Google Cloud Storage using DMS Data Exchange. Create a template and include gsutil script to transfer files to the storage bucket. Then, manually create the tables in the BigQuery TDM dataset via the BigQuery user interface. Select Google Cloud Storage as the source, choose the file by clicking the Browse button, specify the table name, and check the Auto Detect Schema option. Finally, click the Create Table button. This create the table in the TDM dataset. Similarly, create the tables for other TDM system tables. This completes the data transfer to the BigQuery TDM dataset. If you encounter any data issues within the TDM dataset tables, resolve them in the Phoenix model and repeat the process. The next step is to build BDM, Business Data Model. Based on your report requirements, we start generating the BDM relationship views using DMS Data Explorer. DMS Data Explorer generates complex queries without the need for anyone to write code. This process is automatic and unique in the market. Based on your business needs, you can select the necessary parties and all available relationships or appropriate relationships between the selected parties. Choose the view type and give a view name and click on Generate button and enter TDM dataset and click on OK button to generate the BDM relationship view. Copy the BDM relationship view and modify the view based on the columns required to be displayed on the report. Execute the script in the BigQuery. Once you are satisfied with the data required to be displayed on the report, create the view in AdventureWorks BDM dataset. Similarly, you can build any number of BDM relationship views depending on your requirements for reports. Likewise, you can create multiple BDM transaction views according to your requirements by following a process similar to that used for relationship views. The ultimate step in the process is analytics and reporting. Using the BDM relationship views and BDM transaction views, you can build reports using a range of tools such as Oracle Apex, Microsoft Power BI, AWS QuickSight, Google Looker Studio, Tableau, and any other reporting tools of your choice. We appreciate you taking the time to watch this video. Thank you.